The solution for our workshop number 1 is now posted in our course pages. I'd like to just do a quick narration of how to look at these tabs, and you can look at more detail, of course, at the formula and Excel level, but I thought I'd give you a quick overview. The first exercise related to cost and CVP, and we were asked to compute the break-even in one scenario and a target profit in the other. And I just wrote here the general rule is versatile, and that's why I start with it for teaching purposes. There are shortcuts as mentioned, but those would be shortcuts for every single scenario, whereas the generic one will work for any scenario. So that's why I stick to it here. So the break-even first in terms of units, the profit equation is profit equals price minus variable costs, quantity, that's called the unit contribution, and times quantity minus fixed costs. Our first step is to determine what is the quantity. We were given the revenues, which was 60, and then we know the price per unit, which is 40. So the units sold equals the price times quantity divided by the price, right? Revenues divided by price. So we end up with 1,500 units. To find V, the variable costs, we sum the costs that are variable, and they are these three, and those three combined is 16,500. That divided by the number of units of 1,500 gives us our variable cost per unit, which is $11. And our final missing number is fixed costs. Fixed costs are, we were given from the hint here, the sum of those two costs, which is 50,000. So now we're able to solve for the break-even. We set the profit equal to 0. We plug in our variables, 40 for the price, the 11 for variable cost per unit. Q is our unknown, leave that alone, minus the 50,000. We solve for Q, and we end up with 1,724.1379 frames. And we say, wait a minute, we can't have a fractional frame. You could have a fractional if we're selling like rice or flour or beans or something, but not a frame. So we round it up to the next number, 1725, just so that we end up with tiny little profit, right? And that's what we ended up doing to test. We plugged the numbers in. If we plugged in the exact number, then we would get to an exact break even. But by rounding up, we get a slight amount of profit, $25. The next requirement is target profit of 10,000. So same thing. We plug in 10,000 as a profit, and then we fill in the rest as we just did above, 40 minus 11, quantity times Q minus the 50,000 fixed costs, solve for Q, and we end up with 2068.9655. Again, we're going to round up to the next nearest unit because we're dealing with a frame here. So it's 2069. When we do the check on the math, the break even, if we used exactly the number, the 2069.96 blah, 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 we'd end up with 0. But if we round up to the next unit, we get a tiny little extra profit of 10,001. So that's the solution to the first problem that we had related to CVP or cost volume profit relationship. The next exercise dealt with time value of money. Here we had two scenarios, and the tip that I wanted to share with you guys is to use this template because it makes it easier come time to actually set the parameters for the calculation. So let's look at the data. 10,000 goes here because that's how much your aunt has given you. Next is the interest rate is 6% per year, 6% rate, and everything's annual here, so we don't need any other refinement. And 15 years is number of periods, N/PERS, number of periods. The payment is 0 because she's only going to give you money once, not every single year. And we solve for the missing unknown, which is, in this case, future value. End of period is okay since all the compounding and our withdrawal of money is at the end of the 15th year. So our answer, if we plug in the numbers, which is FV, open parens, and it just walks us through. I'll just show you, equals FV, open parens, and you'll see underneath here, it tells you what the numbers are. So you simply point at rate, and then you put comma, and per comma, payment, make sure you put in 0 because it needs that parameter, and then PV, close parens, and you get your number, which is 23,965.58. Now, you might wonder, why is that number negative? And that's a common question, reasonable question. It's because the time value functions in Excel deal with a very simple concept, which I'll tell you, and hopefully you'll be able to remember easily. If you get money, it's a positive. If you give money, it's a negative. It's that simple. So in this case, we're looking at this transaction as if you were a banker, because the banker gets money, and at the end of the 15 years, they will give money. So that's why if this number is positive, That means somebody's getting the money up front. In this case, it would be the banker. And at the very end, they would give up $23,000. Now, you're the flip side. Your aunt gave $10,000. And if I simply put negative 10,000 here, you'll see the signs flip, right? Because here, we gave out $10,000 at PV, and we're going to get 23,000 positive at the end. So the sign in this case could be either way. It just states which of the two parties you are, the banker or the person saving the money. All right, the next example was where we have a house that we're wanting to buy. So in this case, 15 years later, we find a house we want to buy. It's $300,000 price. $75,000 is what you've accumulated to put as a down payment, which means you're short by $225,000. What are you going to do? Borrow it, the American way. So we have the PV is the amount of the loan, $225,000. The rate, now we have to be careful because the rate as given is 5%. However, it's 5% per year, and we're wanting to compute the monthly payment. So we need to convert the rate from an annual rate to monthly rate, which is simply taking the annual of 5% divided by 12. The number of periods is the number of years, 30, times the months per year, 12, to get at 360. The payment is our unknown. The future value is 0 because at the end of the 30 years, we're going to have the entire house paid off. So we end up with a 0 value at the very end. Now, similar to what we did before, we simply put in equals PMT. That's the hint right there. We look at the parameters. I'll just show you right now. Equals PMT, open parens. And we see underneath it says rate N per PV FV type. And that's 0.416. We pointed to the rate. And then the N per is 360. We pointed to N per. The PV is the loan amount, $225,000. And the FV is 0. When we plug those in, we get this number, $1,207.85. Now in this case, the negative makes sense because you get at the beginning a loan, you get money from the bank, and then for the rest of the period, you're going to be paying out money for 30 years or every month for 30 years of $1,207. So in this case, the sign actually makes sense. All right. The third item was on this distribution, and we asked for some of the normal measures of a distribution, which are mean, median, standard deviation. Mean is simply the arithmetic average of the observations. Median is you rank order from top to bottom, and you find the one right in the middle. Conveniently, there's a function in Excel for that too. And then standard deviation is we first determine, is it a population where you have every single observation, or is it a sample? And those have slightly different calculations. In this case, there's been a lot more weather in Lake Tahoe than the last 21 years, so therefore it is a sample. So here I put in the actual formulas for you to look at. That's not how you would normally do it. You would simply put in the formula, hit enter, and you get a number, right? But I put the formulas here for you could see it a little more clearly, all right? And then so if we look at the end results, here's the mean, and you'll see that it's simply the average of that first row or column of data, which is an average temperatures. Same thing for rain. It's the average for the next column, wind, you get the picture, right? So we simply have to put it in for the first cell and then copy it across, and we're done for all four variables. Next is the median. We use the function median. Again, shade the region. We're good to go. Copy that formula across, and we get the medians for the four variables. Last is standard deviation. Again, we're going to use the function stdev.s as in sample. Guess what? Shade the region and hit enter and copy it across. So one extension just to help us understand a little bit better is we like to say, what is the mean? And that's what we would say we'd expect. We'd expect the temperature to be 31.87 degrees in a year from now. And then if we subtract the standard deviation, so 31 minus 6, we get the left edge of the bell curve. If we add 6.02 to the 31, we get the right edge of the bell curve. And that is kind of the shape of the base. The wider the standard deviation, the more variation we expect. The smaller the standard deviation, the more confident we are that that medium will hold up. And here are the answers to the question. First, what should the guest wear? Well, since it's going to be cold, right, 32 degrees, freezing basically, very little chance of rain, and windy, that's gusty at 17 miles per hour. A nice parka with down would be nice, right? Do they need to carry an umbrella? The answer, due to the small amount of rain, is no. If anything, it'll snow, so you don't need an umbrella for snow. So we don't need an umbrella. And then how crowded will it be? We would expect about 689 people. However, it could be a pretty big range, as low as 566 and high as 812. Now, when I say low and high, that's to capture 68% probability. So the way to say it very precisely is a year from now, we would estimate that there would be 689 skiers. It could be as low as 566 and as high as 812. And within that bound, that range, is 68% chance of that number happening. So that's how we would state the results of this particular analysis. The last tab is on regression. This is the most complex of the 4 exercises. A regression takes independent variables and sees if we can create a formula based on those variables to predict a dependent variable. In this case, we're going to say, does a combination or singly the temperature, the wind, and the rain predict how many skiers will be on the slopes a year from now? So we'll do this kind of methodically. We'll do each of the 3 variables individually, and then we'll look at it and say, okay, is there a multiple regression that makes sense? First one here, let's try only temperature. To do this function, we would go data, analysis, and then look for the regression choice right there. Hit OK. And we would then set the parameter for y. Y is the dependent, so we want to know how many skiers there are. Just shade including the label. Then the next will be to ask you, what is the x? What are the independent? And we're going to do one at a time. So let's start with temperature. So let's just do temperature. And make sure we click labels, because the top of this column has a label. And we could do an output range. I'll leave it on a new worksheet because I've done it here already. So if I hit OK, it'll think about it and generate the numbers. Right? So these are the regression results. Now, what are the key numbers? I'll just go back to the other one because I've highlighted it. The key numbers are here, the intercept and the temperature, because this gives us our formula. What it basically is telling us is that the number of skiers equals 234 plus 14.27 times the expected temperature a year from now. And that would be the answer. However, this is bad news. We're not very high. We're at 45%, which again means this function that we just specified explains 45% of the variation. Not very high, right? So let's do the next one. If we do the same thing for the wind, we end up with this regression. And it's even worse, 0.02, like 2% of the variation, not very good, again, by itself. Next one, we did precipitation, rain. What is it? Negative 0.05. That means there's no variation whatsoever explained by the rain. It has no bearing on the results of the number of skiers at all. So ignore that one for sure. And the last one we do is we said, well, it looks like the 2 with good explanatory value were the average temperature and the wind. Makes a little bit of sense. Cold and windy makes you want to stay home and take the ski slope the next day. So if we use those 2, then we get 85%. Now we're talking. So with the function that includes both the temperature and the wind, we could predict with about 85% certainty that we're going to be able to estimate the number of skiers. So let's use that. Again, the function, let's just do it here on the side, equals the intercept plus the temperature coefficient times our estimate for next year, which is 33 degrees, plus the next coefficient, and notice a minus number, because the more wind there is, the lower our estimate for skiers. And that's times the wind speed for next year, which again up here in the given, we're estimating at 15, right? So we'll put 15 here. Hit enter. And now we have a number. We estimate 737 skiers a year from now. So now we're done, is we did the regressions, and it seemed like the best by far was the multiple regression with the average temperature and the wind speed. Here with the average temperature of 33 and the expected wind speed of 15. Our function is equal to the intercept of 245 plus the number of degrees, 33, times the coefficient. Then add to it the negative coefficient for the wind and multiply it times our expected wind speed, and voila, we have a number. And that number is 738 skiers. All right, so that's it. You may want to look at it on your own to have it sink in, but that's how we do a regression. Now, some of you may say, well, you lost me at the beginning because I don't have this fancy little thing here called data analysis. So if you have a blank here, don't worry about it. It's built into your Excel. You just have to activate it. So we go to File, and you go to Options, right there on the bottom. And we'll look at things called add-ins, the Analysis Toolpack. If you click it, I won't do it because I've already done it. Analysis Toolpack, hit OK, and it will activate that item in your Excel. So if you don't have regression, don't worry about it. You can activate it by simply those clicks, and they're explained right. Okay, great. I'll see you in class. Bye-bye. And don't forget to watch the videos for this week. Bye-bye.